Okay, good morning. Our topic for today is all about powers of tangent and secant. So we have to consider the integral form of tangent and secant, which is the integral of tangent to the power of m times v secant to the power of n times v dx. And we have also to observe that the value of m and n is equal to 1, so that we can evaluate the integral form of tangent and secant based from theory number 9 or formula number 9, which was previously discussed during the midterm period. So if m is equal to any number and n is equal to 2, so we evaluate the integral form by the ordinary method of substitution. So by letting u is equal to tangent x, so that we can integrate the tangent form by this expression here. So we have tangent to the power of 3 times x secant to the power of 2 times x dx is equal to tangent to the power of 4 x over 4 plus constant. Now to solve for powers of tangent and secant, we have to consider 3 cases. So case number 1 here is when m is any number and n is a positive even integer greater than 2. Then we have this format here for the pattern. So we have here tangent to the power of m times v times secant to the power of n times v is equal to tangent to the power of m times v times secant to the power of n minus 2 times v times secant square of v. And then we have to use the identity for the secant square of v is equal to 1 plus tangent square of v, so that we can reduce the given integral to the form of sum of powers of tangent v times secant square of v dx, which we can now integrate this one by using I4, and the value of u is equal to tangent u v. Now let's have an example for case number. Okay, let's have example number 1. So we have to evaluate the integral of tangent of 3x times secant to the 4th of x dx. Okay, so we have to follow the format for case number 1 to come up with a solution. So we have here integral of tangent 3x times secant of 4 minus 2x. We have secant square x dx. So we have here tangent to the power of 3x and secant square x times secant square x dx. The integral of tangent 3x times, we have to substitute now the identity of the secant square x, which is 1 plus tangent square x times secant square x dx. And then we will distribute tangent to the power of 3x to the identity. So we have tangent to the power of 3x plus tangent to the 5th of x times secant square x dx. And we will integrate this one by term. So we have here tangent to the power of 3x secant square x dx plus the integral of tangent to the fifth of x times secant square x dx. So the integral of tangent cube of x is equal to tangent to the fourth of x over 4 plus tangent to the power of 6 of x over 6 plus constant. So that's it for example number 1 based on case number 1. Okay, so let's proceed with case number 2. So for case number 2, so when m is a positive odd integer and n is any number, so when we write this principle here or the pattern here, we have tangent of m times v times secant to the power of n times v is equal to tangent to the power of m minus 1 times v times secant to the power of n minus 1 times v times secant of v tangent of v. And then we can use the identity for tangent square v, which is equal to secant square of v minus 1 to reduce the integral form of the sum of powers of secant of v times secant of v times tangent of v dx. And we can integrate this by using I4 with the value of u is equal to secant of v. So let's have an example for case number 2. So example here is we have to evaluate the integral of tangent to the power of 3x times secant to the power of 5x dx. Solution. So the integral of tangent of 3 of x times secant to the power of 5x dx. We now have integral of tangent of 3 minus 1 x, and we have secant of 5 minus 1 x times secant x times tangent x dx. So we have integral of tangent square x and secant to the fourth of x times secant x times tangent x dx. Then we have to substitute the identity for tangent x squared. So we now have secant square of x minus 1 times secant to the fourth of x times secant of x tangent x dx. Then we will now distribute secant to the fourth of x with this identity here. So we now have the integral of secant to the sixth of x minus secant to the fourth of x times secant of x times tangent of x dx. Then let us integrate its term here. So we now have integral of secant of 6 of x times secant x tangent x dx minus the integral of secant to the power of 4 of x times secant x times tangent of x dx. So the integral of secant to the power of 6 of x is equal to secant to the 7 of x over 7 minus secant to the power of 5 of x over 5 plus constant. And that's it for case number 2. Okay, so let's have case number 3 for the powers of tangent and secant. So when m is a positive, odd, or even integer and n is 0, so we have this pattern here. So we have tangent of m times v is equal to tangent to the power of m minus 2 times v times tangent to the power of 2 of v. And then we will use the identity of the tangent square of v is equal to secant square of v minus 1 to reduce the integral form of case number 3. So let's have example number 3. So we have to evaluate the integral of tangent to the fifth of x dx. So based on case number 3, so we have tangent of 5 minus 2 of x dx, or we have to let us remove first dx here. So we still have here tangent of square of x before dx. Then we now have tangent of 3 of x times tangent of 2x dx. The integral of tangent of 3 of x times the identity of tangent square x, which is equal to secant square of x minus 1 times dx. Then we will distribute tangent to the power of 3 of x times the identity. So we now have tangent of 3x times secant square of x minus tangent of 3 of x dx. So in this case, for the tangent to the power of 3 of x, we can factor this out. So we now have tangent to the power of 3 of x times secant square of x minus tangent of x times tangent of 2 of x dx. Then integral of tangent to the power of 3 of x times secant square of x minus tangent of x times. Again, we will now substitute the identity of tangent square of x, which is secant square of x minus 1 dx. So the integral of tangent to the power of 3 of x secant square of x minus tangent of x times secant square of x. We will distribute this one here with the identity minus or negative times negative 1, that is positive rather. So we have tangent of x dx. Okay, let us integrate its term here. So we now have tangent to the power of 3 of x secant square of x dx minus the integral of tangent of x secant square of x dx plus the integral of tangent of x dx. So for the first term, the integral of tangent to the power of 3 of x is equal to tangent to the power of 4 of x over 4 minus tangent of 2 of x over 2, and for the integral of tangent of x, we have negative ln of cosine x plus constant, or we can rewrite this one. So we now have tangent to the power of 4 of x over 4 minus tangent to the power of 2 of x over 2, positive times negative, so that is negative ln of cosine of x plus constant. So that's it for case number 3.